Hello, great mathematicians. Welcome back to our series on matrices. Remember to subscribe, turn on the notification button, and today we are going to look at multiplication of matrices. This is part B. The first part, remember, we said that we can multiply a matrix by a scalar, and we did that successfully. So we can also multiply a matrix by a matrix. So this is what we are going to look at today. We are going to see how we can multiply two matrices together, not a matrix by a scalar, because we did that last time. So how can we multiply a matrix by another matrix? So to multiply a matrix by another matrix, this is the rule that we shall be considering. We shall be considering a row matrix. That will be our first matrix. So the first matrix, we shall call it a row matrix. The second matrix that we are multiplying it with, we shall call it the column matrix. So we shall be interested in multiplying a row matrix with a column matrix. So you first of all multiply the first entry or the first element in the row matrix by the first element in the column matrix. So it is row matrix. It is the matrix that you consider first, the first matrix, then the column matrix. So what you will do, you consider the first matrix as your row matrix, the second matrix as the column matrix. So you first of all multiply the first entry in the row matrix with the first entry in the column matrix. Also multiply in the second entry in the row matrix with the second entry in the column matrix. You multiply them together, then after you add the results together, you add the product together. Okay, hope that is clear for each one of us. Okay, now before we can also do that, we should also know that for matrices to be multiplied together, for the multiplication of matrices to be possible, it is very essential that the number of columns in the first matrix is the same as the number of rows in the second matrix. If this condition is not fulfilled, then we cannot multiply these matrices together. Let's have an example of that such that we can be able to understand it better. Example, given matrix A and B as 7, 8. First of all, what you need to first see is the number of columns in the first matrix the same as number of rows in the second matrix. How many columns? 1, 2. How many rows? 1, 2. So this one is compatible. Since the number of columns in the row matrix is the same as the number of rows in the column matrix, first matrix and the second matrix, so these ones are compatible and they can be multiplied together. So find Roman 1 AB, Roman 2 BA. So if I have A, B, solution, I'm going to have 1, 2, 3, 4, 6, 5 multiplied by 7, 8. So this one is going to become, we said the condition is, or the rule is, multiply the first element in the row matrix with the first element in the column matrix, second element in the row matrix, then second element in the column matrix. Like that, you proceed like that after you add the product. So this one is going to be, the first element in the row matrix is 1, multiply it with the first element, which is 7. We add the product plus, because we are still dealing with this. Okay, so it is plus 2 times 8. So row by column, I first go with this row and the column. I multiply this with this, this with this as I add. So this with this, this with this, this with this, like that. So I start 3 times 7 plus 4 times 8, 6 times 7 plus 5 times 8. So let me repeat this. It is this with this, also this with this, also this with this. 1 times 7 plus 2 times 8. 1 times 7 plus 2 times 8. You go to another one. 3 times 7 plus 4 times 8. 6 times 7 plus 5 times 8. As simple as that. So this one is going to become 23, okay, 53 and 82 if you are to add those elements together. Let's look at Roman 2. If I'm to look at Roman 2, BA, meaning that I'm going to first write B, then I write A. Okay? Now, if we were to look at this, you will find that the first matrix, the number of columns in the first matrix, we have only one column. But the number of rows in the second matrix are 3. And remember, we said that for compatibility, or if we are to multiply these two matrices together, possibly this number of columns in the first matrix should be the same as number of rows in the second matrix, meaning that here I have only one column, here I have 3 rows, so it is not possible to multiply these two matrices together. So what does that mean? Unlike for numbers, unlike for scalar numbers, for real numbers, whereby AB is the same as BA, for matrices it is a different story. AB is not the same as BA. AB is not the same as BA. This is only possible if any of the matrices is an identity matrix. If B is an identity matrix, then AB will be the same as BA. This is only possible if we have an identity matrix. But if this is not an identity matrix and this is not an identity matrix, then these are not the same. Remember, we defined identity matrices. Okay, if you are not conversant with that term, please go back to our videos, find the video where we are talking about identity matrices. So where we are talking about types of matrices, you'll find an identity matrix. Hope that is clear. So you should note this, that AB is not the same as BA for matrices. It is only possible when either of the matrices we are multiplying is an identity matrix. Hope that one is clear for all of us. So for today, allow me stop here, and we shall continue with more examples on this. We shall take some time to give more examples on multiplication of a matrix with a matrix, such that you can be able to understand clearly, you can understand well what we mean when we say multiply two matrices together. Thanks for watching. Come back for another video. Thank you very much.